Thank you, Daniel, and thanks to, I just want to particularly thank Daniel and everybody who worked really hard to put this conference together. This is actually one of my favorite conferences to go to every year. It's a unique set of people that I don't get to see in many other places, and so I'm really glad that you do this, and I'm really impressed every year what a good job you guys do with it. So as Daniel mentioned, something changed, right? So I started at Digium in 2001, a very, very long time ago. And it's because Mark Spencer came up to me and was like, hey, would you like to make money writing open source free software? And nowadays that's a little bit more common thing to do, but back then that was pretty unique and it was kind of special. And so I was like, yeah, that sounds like a lot of fun. Because I learned about this Linux thing and I was starting to use it in a lot of places, and I thought it was really just the best and coolest thing in the whole world. And I'd come to, at a young age, understand how important open source was to markets and the world and things like that, and how it was going to change things. And so it was a really great opportunity for me to start working with Mark Spencer, who is the author of Asterisk, and through that also to work on Asterisk as well. And so it's been a fun ride. But this last year in 2018, the company Sangoma acquired Digium. And for those of you who aren't familiar, Sangoma at the time was probably one of the biggest competitive rivals to Digium, at least from a similar sized company and operating in the same space perspective. And so it was kind of a big deal, and it was a big change. And so I've had a lot of people ask questions to me and say, is everything okay? Are there a lot of changes? How does this impact you? And so I figured it'd probably be appropriate for me to talk just for a moment about that. So from my perspective, I run the Asterisk team, the Asterisk development team there. And it's great for us, because this just means that now, instead of having one or two internal customers that we had before at Digium, we've got those same internal customers, and we've got more additional internal customers from the Sangoma side too, because both companies utilize Asterisk for very important parts of their business. So from a security perspective, it's very good. And from a community perspective, that's good too, because that means there's more resources and time and effort that needs to go into that project in order for it to succeed in all the different places it's utilized. So I think it's probably going to be a win for everybody. And so yeah, I hope that big change, new logo, new name, but it sounds like the project is going to be going forward and going on, and things are going to continue to be developed for Asterisk and things like that. So that's good. All right, so I think Sylvain asked this question, but I didn't get to see the answer. How many of you attended AstroCon this last year? So there's a few hands. All right, good. I don't feel so bad about kind of bridging the gap as far as what happened. So my goal here is to talk a little bit about what's happened this last year in Asterisk, with their latest release, and then talk a little bit about what's coming, or what's happening and what's coming with the project. So for those that aren't aware, Asterisk 16 was released late last year. That's close to 1,000. There are about 1,000 commits in that release, so 1,000 individual changes that went in. And of those changes or commits, there were 72 different individual contributors. And I always like to look at these statistics, because sometimes it's easy for me to get lost in my own little world and think, oh yeah, the world that I live in is the 5 people I see around me, or whatever, or the 10 people I see in IRC, or 15 people I see in IRC, or it's the 20 people I see on the code review website we have, Garrett. But it's much, much bigger than that. For Asterisk, just from a development perspective, there's 72 different people from all over the world that were motivated enough to get through the admittedly difficult code review process for Asterisk, because it's not easy to get code in. It used to be a lot easier. It's not as easy now, and there are reasons for that. They went through that process to get code into the mainline branches. And so I'm really grateful for any of you and for those people for all the work they put into making that happen. And so actually, yeah, 16 came out, and it's been a while, and we're up to 16.3 now. So there's been a few releases since 16.0. I just want to talk a little bit about releases in Asterisk land. We have standard releases, and we have LTS releases, much like other open source projects. And those mean different things for different projects. For us, it means a standard release usually receives a year of bug fixes or improvements. And after that, it receives a year of additional security fixes, but only security fixes. It doesn't receive normal bug fixes anymore and things like that. And some examples of branches that are standard releases are the 12.x branch of Asterisk, the 14.x branch, and the 15.x. LTS releases. So this is a magical acronym for a lot of people. A lot of people like to go from LTS to LTS. And so this is probably important to talk about from Asterisk's perspective. And what that means to us is the branch receives about 4 years of bug fixes and 1 additional year of security fixes. And some examples of that are the 11.x branch and the 13.x branch. And so, we were a little bit naughty with 15, and we did not turn it into a LTS release. We made it just a standard release, and there were reasons for that. So historically, the odd number releases of Asterisk, like the 11 and the 13 major number releases, were LTS releases. But we made some really big changes in preparation for release of 15. So the code that went into 15 included some large changes to the core of Asterisk that I talked a little bit about last year, but were mostly about removing some limitations in the core of Asterisk, some core assumptions that had been made about calls and about one audio or video stream per call and things like that, because we wanted to turn Asterisk into a video SFU. We thought that'd be really cool if you could do that. And so we did a lot of work to some ugly parts of Asterisk that hadn't been touched in a long time to make that happen. And we just wanted to be very certain that those changes were ready, they were stable, they were happy, and that any of the programming interfaces we created, they were good programming interfaces that we didn't want to adjust or change after doing that. And so we decided to make 15.x, the 15 branch, a standard release in LTS instead of an LTS. And so 16 has come around, and we decided that to fix what we did and make 16 an LTS. So we broke convention, 16 is now an LTS, and probably going forward, the even number releases will be LTSs unless we do something silly like we did with 15. And so it'll be around for bug fixing at least until 2022, and it'll die towards the end of 2023. It'll receive security fixes till 2023 and then die from a development perspective and maintenance perspective. I want to talk briefly about what went into Asterisk 16. And I love chocolate chip cookies, so I decided to put them on this slide. I'm trying to get better at my picture game in my slides because I do a lot of boring engineering slides. And so I'm, little by little, right? Improvement. Like Mr. Duffett does the let the geek speak. And little by little, I get a little bit better over time. Or I hope I do. So we'll talk about some of the things that went into Asterisk 16. So Asterisk 16, we wanted to continue working on some of our video efforts that we started in Asterisk 15. And so we wanted to improve some of the ways that we responded to video packet loss and things like that. For those that aren't familiar, in an ideal network environment, video is perfect and it runs great. But we learned that most network environments, particularly those that involve Wi-Fi routers, they're not ideal networks, and packets get dropped or mangled and things like that. And what does that mean for video? It means that you have artifacts, video corruption, you have body parts flying across the screen that aren't connected to bodies anymore, and it's really uncomfortable for everybody that's involved, and it looks kind of tacky too. And so for packet loss situations in Asterisk 15, we took a really big brute force approach in that we requested, I'm just checking my time, make sure I don't go over. We requested a full new video frame every time we detected significant packet loss. And that works, it does the job, but it's pretty bandwidth intensive to do that. Every time you detect a packet loss, instead of getting the compressed frames, you have to get a full new video frame to start over again. That can take a lot of bandwidth. And there's a lot of better technologies for doing that that don't take nearly as much bandwidth. One is called NAC, and it's exactly what it sounds like. It's a negative acknowledgement. And so for RTP, for those of you that are familiar with the RTP protocol, it's just a stream of audio or video packets that come in, and each one has a number on it, so you can identify it. 1, 2, 3, 4, 5. And what you can do is, if you detect that one is missing, you can send this negative acknowledgement back to the other side as a NAC, and you can say, "Hey, I missed packet 4. Can you do something about it?" And the other end has the option to do something about it. Can try to retransmit the packet, and you can correct the video issue. in a lot lighter way than resending a whole new video frame. Another one is called Rebbe. It stands for Receiver Estimated Maximum Bitrate, and basically what it is it's the video streams, the receiver of the video stream's perception of how much received bandwidth is being taken up by that video stream. And you may ask why that's important. There are situations where sometimes you have, for example, let's say you have somebody on a 64 kilobit link and you're trying to make a video call to somebody else who's on a 1.5 meg link, right? The transmitter can try to send a 1.5 meg all at once down to the other end, but the other end's only going to receive 64 kilobits worth of packets, right? So if, from the receiver's perspective, he's going to say, it looks like I'm getting a lot of missed packets. Let me just send that negative acknowledgement back, and then you can retransmit it, right? You can imagine how well that would go, right? You're never going to catch up in that situation. There's no way that you can retransmit those packets because there's just not enough bandwidth available on the receiver's pipe, right? And so this is the way the receiver can tell the other end. This is, I don't know what you're trying to send, but this is what I'm calculating that you're sending to me. And it can send that back to the sender and say, okay, I'm only getting 64 kilobits from you. And the sender can say, oh, crud, I gotta readjust my video encoding rate down to something a lot lower, like within a 64 kilobit window, right? And you're instantly in a lot better situation in terms of, not having to retransmit a bunch of packets and never be able to catch up and things like that. I want to talk a little bit more about enhanced messaging, which is the ability within Asterisk to be able to do a lot more fun things with messages in AppConf Bridge and within bridges. And just as a background, how this kind of came to be, I showed many of you who were probably here last year or maybe at AstroCon some of the engineering prototype that we built to test out our video SFU code. And none of us are front-end developers, unfortunately, so we're very proud of this, but it does very much look like it's made by a bunch of C developers, right? There's wireframes here, and there's simple buttons and things like that. So patches are definitely welcome on our prototype implementation of the SFU front end. But we did this and we created it and we're like, this is really cool. We can all see each other at the same time using Asterisk, right? You can instead of having mesh topologies between browsers and stuff like that, you can have all the video going to Asterisk and it can route it to the right people and things like that. And we thought it was really awesome. And then a little bit further down the road, we realized that there was something missing here. So from a user perspective, you can see, or at least I know, that guy right there is Kevin, because I can see it in the video frame. I work with him. I see him every day. But, as an application developer, I don't see a name up there. And it's kind of fuzzy, but you can see it says local video. It says remote video. There's a mute audio, mute video button here. But there's no name there, right? Your application, your web application, has no idea who that is. You as a user of the application does, but the application itself doesn't know. And we realized that we'd missed something very important in terms of APIs that we needed to make sure that we provided, from Astra's perspective, the ability to correlate, this guy right here, this video element right here on the web page. It has an ID, but there's no way to correlate that video ID or that video label to caller ID information or something like that, or other participant information that maybe Asterisk knows about, but the application writer on the client doesn't have a way of correlating with that label. So we took a step back and decided that we need to fix that. And so we now ConfBridge, Asterisk conferencing application, has the ability to send participant level information and metadata that allows them to correlate that video stream with caller ID, maybe a channel variable, unique ID, or something like that. Any sort of information you might attach to an Asterisk channel that could be useful in building better client-side applications. Or even something to map things up to a database in the back end to be able to exchange that kind of information. And it allows you to build much richer and more complete client experiences as well. So we fixed that. We also, since we were there were some other reasons for this, but we decided to add support for participant-to-participant messages. So you can send SIP messages between participants in an Asterisk conference. So if you want to build if you want participants to be able to send text messages between each other. Or we even added MIME support, so you don't even have to send text. You could send other MIME types and things like that. Like you could send images or base64 encoded data or whatever you want to do to continue to build more rich client-side applications. Let's see. Let me check my time real quick. All right, so there was a great talk at AstroCon last year about performance differences between ChanSIP and ChanPJSIP. Is anybody not familiar with what raise your hand if you don't know what ChanPJSIP is. That's wonderful, because I don't have to talk a whole lot about that, right? All right, good. So PJSIP is the newer channel driver. It's the successor to ChanSIP. And there was a talk that was at AstroCon in a previous year that they had brought up some specific scenarios, not in all, but there were a few specific scenarios where they saw some performance advantage using ChanSIP instead of ChanPJSIP. And obviously, we want to, as developers of the project, we want to make sure there's no good reason, particularly from a performance perspective, to stick with ChanSIP. We want to make sure that people have very many good reasons to move forward to ChanPJSIP. And so we took a look at it, reproduced it, and we're able to figure out what was going on, and we're able to improve some things. And if you'll notice on the left, there's some pretty graphs here. And the blue is ChanSIP, the red is ChanPJSIP. And the graph on the left is before we fixed it, and the graph on the right is after we fixed it. And if you'll notice, this is percentage of CPU. It's a little bit higher when you're looking at SIP registrations per second. You can see that ChanPJSIP uses more CPU when it's processing that same registrations per second load. That was previously, before we fixed it. And there's probably about a 6 or 7% difference you can see approximately across the board, across all loads. And so we decided to fix it, and so we brought it down so that ChanPJSIP is more performant. It uses less CPU than ChanSIP does under the same call loads, which is really cool. And so you can say, yeah, that's really neat. It's better. It's another good reason to move forward. But if you'll notice, there's a couple interesting things about this graph. Under the 350 registrations per second column or section there, there's no data for ChanSIP, and there's a reason for that. It's because ChanSIP was not able to handle the retransmission load at that point. It was a simple dual-core Celeron system or something like that we were testing on. So it wasn't a big beast. But when you're doing performance work, it doesn't matter how big the system is. It's all about optimizing against itself, right? But you can see that ChanSIP couldn't handle anything past 300 registrations per second. And so we thought that was pretty cool, actually. And so we took it out a little bit further. And on this very simple multi-core system, we realized that with ChanPJSIP, you could do a lot more. And we took it up to about 2,000 registrations per second. And so this kind of demonstrates one of our big goals with ChanPJSIP was to multi-thread the SIP stack, so make it so it works better in multi-threaded, multi-core environments. And you're seeing the benefits of that there, because it's able to better take advantage of all those CPUs and scale up to higher performance and things like that than you can with ChanSIP, which is great. All right, so let's talk for a few minutes about what's next, what's happening, what's been going on this year. And I'll just talk about some of the features that we've been developing and that we implemented. This is actually requested at Astro DevCon, and we got the opportunity to work on it this year, which was really cool. But essentially be able to do ARI without having any dial plan, no extensions.conf. For those of you, any that utilize ARI, could you please raise your hands in maybe your network or different interfaces? So there's a few of you that probably might appreciate this. So ARI is Asterisk REST interface for those that aren't aware. And you can build telephony applications on top of Asterisk using RESTful type calls and things like that. Previously, if you wanted to have a REST application begin on a call in Asterisk, you had to create a little bit of dial plan that contained a dial plan context and an extension that started in the stasis application. And it's a really, I think, a poor name, but when you put an application or put a call into the stasis application, that's what hooks it into the ARI application. Like you can start controlling that channel from ARI. So what we did was we made it so that this little dial plan snippet is dynamically generated. So anytime an ARI application is registered via the WebSocket, this is automatically generated, and it's got a specific naming convention. It starts with stasis dash and then the app name. And so what you can do in your SIP configuration, your PJ SIP configuration, or your Chan SIP configuration, if you use that, you just set your context to be stasis and then whatever the name of your app is, and you don't have to have any extensions.conf. So that's kind of fun. We added the ability to move channels that are within an ARI application to be able to move them dynamically to another ARI application if you want to do that. So let's say you had a channel that's in an ARI application that's doing your voicemail or something like that, and then you wanted to move it to, you have another application to do hang-up logic or something like that, pre-hang-up logic, and you want to move it to that afterwards. Before you would have had to exit to dial plan and then call stasis again with the hang-up logic app. With this, you can just call the move method from ARI, and you give it the channel ID of the channel, you give it the app name, and then you give it the arguments to the application. You can move it directly there. And so it allows you to further be able to get rid of some more dial plan that you might have had to use. This is actually really fresh, but we added this within the last week or two here, and that's transport CC support. It's a WebRTC technology, and it's like REMB in that it's to help do bandwidth estimation and video encoder control and things like that. It's a transmitter or a sender side bandwidth estimation and management method, and there's a lot of details and things like that about it. But what it means to me and to you is that this makes Asterisk a lot more able to dynamically. So the problem we found with REMB, which was the technology I talked about earlier, was that it would take a long time for, if you had a situation where bandwidth is impacted, let's say you had a temporary restriction in bandwidth due to, somebody started their YouTube video in the middle of your video call, right? And they just took up half of your, bandwidth up, right? You'd see a big quality drop on your video call. And then after some time, they're going to turn their YouTube stream off, and then that bandwidth is freed up. Well, we found there was a significant hangover time associated with REMB. It would take the browser a long time to ramp the quality of the call back up. And that was a little bit frustrating. It makes the user experience less fun and less pretty and feel less nice. And so after adding transport CC support, we saw that ramp up a lot more quickly. So after that transient network condition freed up or whatever, the YouTube stream got turned off, you saw that the video quality would go up higher a lot quicker. It was much more pleasant. And so we're really happy with that, and we're going to be continuing to do tests on it and things like that and seeing what other kinds of conditions that it improves. But we're really glad to see that technology and put it into Asterisk. So in closing, I just have a few reminders. For those of you who are, hopefully many of you are not using Asterisk 14 still. But for those of you that are, it went end of life at the end of September, and so it's probably a good time to move forward. That means no bug fixes and no security fixes. Asterisk 15 has recently, and that's towards the end of last year when we released Asterisk 16, recently graduated to security fix only mode. That means that you've got, you got a few more months left until it's going to be gone. It's receiving security fixes only right now, and about October time it'll probably be to the point where it'll be end of life. I would recommend for those of you that run Asterisk in your network and you stick to the LTS only strategy that you maybe take a little bit of time between releases to make sure you understand what's going on. One of my responsibilities as project lead, or one of the things that I try to do, is make sure that upgrading Asterisk is as boring as possible for you. And I mean that in the best way possible, that there are no surprises, no unintended consequences. If there's new functionality and features, that they're done in such a way that you have to explicitly enable them and things like that, unless it's something that's very important that we have to change for important reasons, right? But generally, that's the exception rather than the rule. But it's always good to make sure that you're aware of what's going on in non-LTS releases, because that gives you the opportunity to, if you see behavior change that was unexpected and it was a mistake, not intentional, that gives more times that can be corrected before you migrate to the next LTS. That's it from my perspective. Thank you very much for letting me come and talk for a few minutes at this really awesome Kamailio conference about Asterisk. I think I don't have anything else. Does anybody have any questions or anything like that? Is there time for questions, Daniel?
Thank you. Yes, sure. I'm sure there will be some questions here. First, Dragos, next one.
You were speaking earlier about resilience methods. Yeah, and I was wondering if you're planning to implement ULP FEC, uneven levels of protection.
Oh, man, that's a good question. Good question. Oh, man, this is great. See, this is why I like this audience, is because there's like a lot of people that, anyway, that was really good. ULP FEC, yeah, I keep on thinking, I keep on questioning if we should do ULP FEC. The problem with it, though, is that it's not implemented across the board. I think only Google's doing it, and I don't think Firefox or Edge or Safari are doing it. And so we've been really focused on, our original intent was to focus on technologies that would probably be adopted across the board. And so at this point we haven't, but I think that if somebody submitted it though, if somebody wanted to make a patch to do it, I think that I would be super excited about that. So anyway, I don't know if that answers your questions, but that's what I got.
So I want to plug my session for tomorrow because I'm going to talk a lot about both REMB and AltFEC. So yeah, kind of try and remember what Matt said, and then that means I have to say less, hopefully.
You'll probably say it better, Tim. You'll probably say it better.
Yeah, probably not, actually. But anyway, there you go.
Okay, maybe one of the last.
You've talked about in the Asterisk 16 more about video and all of this stuff. Do you have to plan to add the multiplexing of the video on the conferencing? So not like each channel, but some kind of actually multiplexing of the video.
Like a MCU?
Yeah, exactly.
Yeah, right now we decided, we made a decision a couple years ago. We're looking at the MCU market and SFU market, and we kind of decided to take the SFU approach. So right now, at least from my perspective and the team that I have control over, we are taking the SFU first approach. So that's what we're doing. If somebody else contributed, it wouldn't be hard to add MCU support. And actually, MCU support wouldn't have needed all the changes that we made to the core of Asterisk 2. So it wouldn't be super difficult for somebody to take some of the open source graphics libraries and things, and codecs, video codecs, and build a video MCU into Asterisk. I don't think anybody's done it yet. So SFU is where we're focused on right now, at least. But if somebody submitted that, I think it'd be super awesome too.
Okay, thank you then, Matt, not to make it longer.